Hi 9p. So last day we were looking at what happened whenever we were applying forces to levers. So remember, a lever is just something that is free to rotate about a pivot. And the type that we're looking at here really are very similar to seesaws. Okay, so here's my lever and here's my pivot. So say I set something, a box A, on my pivot. It's going to have a weight, and that weight will be a force. Weights are forces. So if I was to set this on my seesaw, well, we all know what's going to happen. It's going to rotate. So the force being set on a lever creates a turning effect, and that's going to make that rotate. And we would say that it's going to make it rotate clockwise or anti-clockwise. So in this situation, if our pivot is here and our force is acting down here, it's going to be turning anti-clockwise. So you can do that. You can follow the force around with your finger to figure out whether it's clockwise or anti-clockwise, or I think this way is a wee bit better. If you set a pen or something on top of your lever and you pivot it at the pivot and rotate it the way the force is going, then it shows you what way it's going. So it started off here, this is moving anti-clockwise. So we would say that this object A is creating an anti-clockwise turning effect, or the other word for turning effect would be moment. So this box A would be creating an anti-clockwise moment. So what we're going to be looking at today is actually calculating that moment. Okay, the equation that we use for that is moment equals force multiplied by distance. So the force is just the force that's being applied, and that can either be the weight of an object or it can be something pushing with a certain force, and the distance is the distance from the object, so in this case from the center of the object to the pivot. So that would be the distance that we are using there. Okay, we do need to think about our units. So force is measured in newtons. Okay, distance is measured, let's say it's in meters. Then that means we're multiplying newtons by meters, and that just gives us for moment Newton meter. So it's as simple as that. You can always figure out units from your equation if you ever forget them. We're multiplying newtons by meters, we get Newton meters. Now, say our distance was in centimeters, then we would be multiplying newtons by centimeters. So our moment would come out in that case in Newton centimeters. Okay, so big things I need you to learn today are this equation for calculating moments and these units. Now, let's have a quick look at our notes here and fill things in. So I'm on page 60 in our notes, and this is just the notes on everything I've just been talking about there. Make sure you learn this equation, and remember, we don't have to write it out in words every time. It's perfectly fine to write m equals f multiplied by d. A couple of points I want to make. Moment depends on both the force, which can be a weight or just the pushing force, and the distance to the pivot. This is the formula we use, moment equals force multiplied by distance, and remember that that distance is the distance between the object and the pivot. Sometimes they'll be sneaky and they'll give you a different distance. Units, force is measured in newtons, distance is measured in meters. The unit used for moments is, I'm going to write it in words as well, Newton meters, which N, M. Proper capital N for newtons here and a small m for meters. If you do a small n, I would mark that wrong because it's not right. It's a capital N that we use. Now on page 60 there are a couple of examples, but I'm going to leave those for whenever we're back in class. I'm going to do some extra examples. So if you get yourself a page so that you can write these down, please. Okay, so pause the video so that you can get this written down. Done? Right, let's have a look at it. So for my examples, I'm always going to be referring back to this diagram because this is the format that your questions are going to be in. So in all these questions that we're looking at today only, we have our object A, and it will have a weight, which is the force acting down the way, and it'll be a certain distance from the pivot. So for our first example, we have to calculate the moment produced when box A is 3 newtons and the distance D is 7.4 centimeters. First thing we need to do for every question is list the information that the question has given us, because it really will help us remember the equation, and by the time we get to the stage where we have lots of equations that we need to remember, it'll help us pick out which equation we have to use. Okay, so 3 newtons, we know Newton is the unit of force, so that is a force. So force equals 3 newtons. Distance d, 7.4. And the question's asking us to calculate the moment, so I would write m equals question mark. Okay, and hopefully you can see that by listing these all together, that will trigger alarm bells in your head to hopefully remember the equation moment equals force multiplied by distance. Now, the way I'm setting my working out here is how we always set out our working out. So moment equals force multiplied by distance. Write the equation every single time. There will be 1 mark for writing that. Then all we do is substitute in the numbers that we know. So moment we don't know. Force we do know, it's 3. Multiplied by the distance we know is 7.4. There will be another mark for showing that. Now, just like in maths, we work down the page and we line up our equals signs. Now we figure it out. So moment equals 3 multiplied by 7.4 is 22.2. You're always allowed a calculator in physics. And then we have to figure out our unit. We would always put units on our answers. So we refer back here, our force is in newtons, good, and our distance was in centimetres. So that means our moment is going to be in newton centimetres. Okay, so there would be 1 mark for your numerical answer and 1 mark for your unit. So make sure you copy that out exactly like that. And all of our questions, we need to make sure that we set out exactly like this. Okay, so here's example 2. This one's a little bit more awkward. So this time, box A creates a moment of 15 Newton meters when it is sitting 4 meters from the pivot. What is the weight of A? So let's make our list of information. So our moment, this time it's given us 15 Newton meters, and our distance is 4 meters. Have a quick check anytime you're given things like that, that these actually match up. So meters and Newton meters, good, they go together. If they'd given you the distance in centimeters, you would have to convert it into meters to make sure it matched with your moments. And it's asked us for the weight. Well, in this equation, weight is just stated as force, so force equals question mark. Now, you'll notice that this time our equation isn't quite in the correct form. So if I have moment equals force multiplied by distance, use your math skills. We're looking to get force, so we want force to be the subject of this equation, which means we want it to be on its own on one side of the equal sign. So currently force is getting multiplied by distance, so we have to do the opposite of that, and the opposite of multiplying by distance is divide by distance. So if we do our lines down both sides like we were in maths, divide by distance on both sides to keep our equation balanced. Then moment divided by distance, we just write that as m over d equals force multiplied by distance divided by distance. We're just left with force. So our rearranged equation is force equals moment divided by distance. I'm off the screen, give me a second. Okay, there we go. So this is just this moment equation rearranged. Okay, so force equals moment divided by distance. Now I'm back to my example. We know the moment is 15 and the distance is 4. So 15 divided by 4 gets 3.75, and my unit for force is newtons. So by setting my working out properly like this, I've got 4 marks. 1 for this, 1 for this, 1 for this, and 1 for this. Okay, now make sure you get that written down, and then we'll move on and do our next example. Okay, so here's our third example. Again, you're going to have to write this one down. So how far must box A be from the pivot if it weighs 7 newtons and creates a moment of 25 Newton centimeters? So let's make our list of information. The first bit of information that we've been given is its weight, which we know is the force. So that's 7 newtons. We know the moment is 25 Newton centimeters, and it's asking us how far. Well, that's the distance. So distance is what we're trying to figure out. So again, bit awkward. We have to rearrange our equation. Let's look back to this. Well, moment equals force multiplied by distance. This time, it's the distance that we're trying to figure out. So we need to get this distance to be on its own on one side of the equal sign. So currently that is getting multiplied by the force. So we have to do the opposite of that. We divide by force, and we have to do that on both sides of our equation so that our equation stays balanced. So moment divided by force, so we write as moment over force. Force multiplied by distance, and that's getting divided by force, so we're left just with distance there. So our version of this, which has been rearranged, distance equals moment over force. Okay, and if I was you, I'd be writing down all three versions of this. Now you just have to learn one version, but as long as you can rearrange it then to find the other ones, you're fine. So this one here in the red box, that is the equation that I know, and then if I ever have to use this to figure out a force or a distance, I'll just rearrange it. Okay, I like to use my algebra skills to rearrange. At the end I'll show you a wee easier way that you can rearrange if you're not so confident with your algebra. But it's good to get extra practice at it. Anyway, back to the example. So we've got our information, we're trying to find the distance, so it's this version of the equation here that we're going to be using. So distance equals moment over force. The moment is 25 divided by the force, which is 7. Now I've picked this one to show you an example with awkward numbers. So if I'm typing this in here, 25 divided by 7, do you see how that gets me a big long number? I'm just going to round it to 2 decimal places. So 3.57, my next digit is a 1, that tells me to round down. So 3.57. Now, let's think about our units. Well, our, oh goodness me, look, I wrote this down wrong. 25 Newton centimetres and I wrote meters. Did you notice? I hope you did. Well, our moment is in Newton centimetres and our force is in newtons, so that must mean our distance has come out in centimetres. Oh, it's a good job I noticed that mistake. And again, we will have 4 marks, 1 for the equation, 1 for substituting in our values, 1 for our answer, and 1 for our unit. Okay, so I'm going to be giving you, I think it's 10 questions I've picked out for you to do, and they will be exactly like either example 1 or example 2 or example 3. So you're either going to have to calculate the moment or the force or the distance. To know which one it is, for every question, make your little list, and then that's going to tell you which version of the equation that you have to use. Okay? Now, one last thing. I said I was going to show you like an easier way that you could rearrange your equation. So if I draw this up here, we can use these little equation triangles whenever we have an equation like this which has 3 things in it, and we draw it like this. So moment equals force multiplied by distance. Because I've got force multiplied by distance, these two are going to have to go in the bottom of my triangle, right? Force multiplied by distance, and then moment is going to have to go up here. Now, this triangle here, drawing it in an exam will get you no marks. You must write the equation, and an equation has an equal sign. If you just wrote force multiplied by distance, that's not an equation, you're not going to get the marks. So you write your equation in full like this. Okay, and the triangle is just to help you rearrange if you're maybe not so confident with your algebra, but I really would love you to give it a go with your algebra because it'll help you out in maths as well. So the way the triangle works is you take the version of the equation that you know it off by heart, you write it in the triangle, and then if you cover up the letter you're looking for, it tells you what you have to do. So if you're looking for moment, force multiplied by distance. If you're looking for force, cover that up, moment divided by distance, which is that one. And then if you're looking for distance, moment divided by force, which is that one. Okay, so this is like a last resort for rearranging. You learn this, you rearrange to make either of these things the subject depending on what you need, or you can use this to do your rearranging, but in all of those you need to learn this off. Okay, so I have attached a worksheet with questions. Answer those, and for every question show you're working out in full. You should have this every single time. Okay, see you next day.